Hello, today we are going to implement a fight game similar to Mortal Kombat in HTML canvas plus JavaScript. We're following the YouTube tutorial JavaScript fighting game tutorial with HTML canvas by Chris courses. So some of the older fight games, there's Mortal Kombat 1992, entire genre with its Wikipedia page for fighting games. There's Street Fighter 2. And now let's create our directory where we're going to work. So let's create a directory, fighting game. Let's open Visual Studio Code in here. And let's create the first files. We are going to need a file named index.html, a file named index.js. Inside of the HTML file, index.html, we will have an HTML canvas. This canvas. Let us open this file in Google Chrome. So right click on the file, open with Google Chrome. There's not much to see. Let's have them side by side. So we have the source code in the left hand half of the screen. And in the right half of the screen, we have the web page in its human readable format. If we look at the page source, we're going to see the HTML source code behind. So this is the human readable format. This is the programming language source code. We can also inspect. So inspect shows us the source code of the page at this instant, whereas right click view page source shows us the source code behind the HTML web page at the moment that the web page has been loaded. Let's look again at the instant source code using the inspect functionality in Google Chrome. So HTML had body, and end of body have been inserted automatically. We have only added this part. The first thing that we want to do, because the canvas is too small, just 300 pixels by 150 pixels, we want to resize the canvas. For that, we're going to go into index.js. We're going to use the JavaScript programming language. Let's find the canvas in the document object model of the HTML page. We have document, and then we're going to query selector, and the name is going to be canvas. Semicolon. Okay, let's zoom in a bit. This. Next up, so we have the canvas, which is an HTML element. We want to do actions on it, run JavaScript code that's going to paint things inside of the canvas, repaint the canvas, set colors, etc. So for that, we're going to get the context of the canvas. Let's use C for the name of the context, local variable, canvas, and then we're going to get the context. we have the option 2D, which is yes, that's what we want. Next up, we'll resize the canvas. We have, for instance, the properties height. Let's make this 576p, so that's 1024. The other. So 576p. That's 16 by 9, which is a common aspect ratio. Okay, let's close the what's new. Let's save everything. There's file save all, but there's no shortcut for it set in Visual Studio Code by default. We can refresh index.html. Let's look at the size of the canvas. It's still too small, 300 times 150. It's certainly not 576p. Why is that? Because we're only running index.html, and index.html does not know about index.js. So we do that in index.html. We tell it this is the DOM document, this is the only thing that we're defining in a canvas, but we also need a JavaScript file. So for that, we're using the HTML tag script. With a source index.js. Okay, let's save this thing, reload. And now we can see that the size of the canvas is what we wanted, 556p. But we cannot see visually anything, only if we hover on top of the canvas here. Then it becomes highlighted. Okay, let's move this rectangle, which is the tool window developer tools from the web browser Google Chrome. So this tool, developer tools, Ctrl-Shift-I. Let's move it at the bottom. Let's hide the console for now. Next up, we want to have the web page have one color, but the canvas be in a different color, such that we can see where the canvas starts and ends, where is the actual rectangle of the canvas. Okay, so for this, inside index.js, we have the canvas context, which we can use in order to paint. So we're going to call JavaScript methods on this class, which is the context. So we go fill rect, and let's look at the parameters. So there's coordinates x and y, width and height. Let's see how the coordinates work. Okay, so this is a monitor, computer screen, and the coordinates work like this. This is the OX axis. So in here is the width, and this is the OY axis. So it goes 0 in here, and then 1 and 2 and 3, etc. And on the y coordinate 1, 2 and 3. So OY increases descending, so 0, 1, 2, 3, and OX increases from left to right. 0, 0 is the top left corner, and the width of the computer monitor, the point with the width of the computer monitor and the height of the computer monitor will be this point, the last point to be displayed on a monitor. So this is the first possible point, and this is the last possible point. Okay, so we say, please create a rectangle that starts at the first point, which is coordinate 0, 0, and ends at the last point, which is the width of the canvas, and ends at height of the canvas. Okay, let's refresh. And now we can see that the canvas is painted black. The rest of the HTML page is painted white. And we have a left-right scroll because we specified the width of 1024, which cannot currently fit in the width of the web browser. We can shrink the web page. That would be Control scroll. If you go 90% zoom in Google Chrome, the entire canvas will be visible at the same time inside of the web browser. We can reset the zoom either by clicking on this button, go reset, or we can go Control 0. So we can go Control minus and Control 0, or we can go Control scroll down, Control scroll up with the mouse scroll button. Next up, we will create two players. So a player and an enemy. And we're not going to have detailed graphics. First, we're going to increment, and we're going to actually start with two rectangles. So one rectangle for each player. And we'll do custom painting for all of these two players. And we'll increment from there. We'll add movement, gravity, etc. And the actual final graphic. For this, we will not go canvas context, which is C, fill rect, and just paint rectangles. We will do object-oriented programming. We'll have a class, which is the definition of how an object looks like and what properties it has, what methods it has. And we're going to have two instances of that class. So the class is going to be called sprite. Let's say put a trailing new line. Okay, so we're defining the class sprite, which is the template for the two instances, the two objects that we're going to have. First of all, we want a constructor for the class. And the most important thing that any sprite has is its location on the 2D canvas, two-dimensional. So we want in the constructor to have as a field member of the object a position. So this should be per class, per object, not per class. So we go this, and we're going to receive via the constructor the starting position. Okay. Next up, let's create the players. The first one is going to be called player and the other one is going to be called enemy. We call the constructor of sprite. And we're going to need to pass this position thing. It's not typed. There's no strong typing here. Could be a string, an integer, but could also be a JavaScript object, which is what we actually want to have. So it's going to be an object that has two data members, a x and a y. And now that we have an instance of the class sprite, the object player, we can inspect it, for instance, using console log. And we're going to print the current object. Okay, let's look at the JavaScript console. Nothing happens in here. And now we're going to refresh the page. And in the JavaScript console, this time we have a result of console.log player. Says that player is an instance of sprite with positions x and 1, 0 and 1. So we want it 0, 0. Let's save, refresh, and it's indeed position x0, y0. Next up, the player exists, but is not placed on the canvas. There's no painting being done on behalf of this object instance. So for that, inside of the class sprite, we're going to create a paint method, which we're going to call draw, which does custom painting. And we're going to use the canvas context whenever we need to paint. So c.fillRect, and the current position is 0.0, which is here. And we want to paint a rectangle like this. It goes from 0.0, is taller than wide. So this is, we're getting the values from the object, object's position, and position is also an object with two elements. We have an x and a y. So x. This dot position dot y, and a width and height. Width 50, height way taller. So people are vertical, which means they're taller than wide. Okay, let's refresh. And now the player might have been drawn correctly or not. We do not know, because when we call fillRect to fill the entire canvas, we fill it with the color black. then we do not change the color to be used for filling rectangles, so the color remains black. And then we fill this rectangle, so this rectangle here. In order to see and not to paint black on black, we're going to need to select a different color for the player, so different than the color of the canvas. Okay, so let's change the color that's being used for filling rectangles in this case. So c dot fill style. Let's make this thing red. Let's refresh. There's nothing being painted. Why? Well, because nobody tells the method draw of the object player. Nobody calls this method. So let's actually call it player.draw. Let's see now. And here it is. So we expected it to start, a rectangle to start from position 0, 0, which is where it starts. Go 50 pixels width and triple that size on the height, so 150, which is, it worked correctly. Now that we have the player being painted correctly, we said that we would have two sprites, two players. The second one is going to be called enemy. So this thing is enemy and paint it here. We should not paint the enemy at the exact same coordinates as the player, because then we're going to paint on top of each other. So let's put the enemy on the right hand side of the screen, and maybe not exactly at the top. Refresh. So there's 400 pixels between the top left corner of the player and the top left corner of the enemy. And on the OY axis, this is 100. Okay, so now we have two objects in a two-dimensional plane on a canvas. These objects actually move, and they're affected by gravity. By default, all of the objects drop at the bottom of the available space, but doesn't exit. The objects do not exit the canvas, but they sit glued to the bottom of the canvas because of the gravity. So gravity is a force that acts in this direction, in the OY direction. And then there's also velocity, which says in which direction the object is moving. So if it's moving to the right, it's going to have the x increasing. If it's going to move to the bottom, it's going to have the y increasing. And we're also going to have a infinite loop that is the main loop of the application, which in this case handles animation, moving. So let's implement the main loop of the application. This is a JavaScript function. Let's name it animate. And we're going to use the object window and then request animation frame to call the function animate. So what this thing does, once somebody calls the function animate, let's call it, the function animate is being executed, which requests that the window, which is part of the HTML document object model, we'll do an animation frame that will call the function animate, which will execute the body of the function animate again, which will request another frame which will call the function animate again, will execute the body of the function animate again and again and again and again. So the line 37 will be called thousands of times per minute. Okay, let's prove that that thing happens by using the console log. And write anything in here. One animation refresh. And we can see that one animation happens multiple times per minute. Thousands of times per minute. Okay. I'm not exactly sure how the request animation frame works, but if this does not do a micro sleep, should do an infinite CPU loop, and this should be extremely fast, like should do millions of times the body of the function animate is called per second. So maybe there's some default time that request animation frame sleeps after calling the function or before. So we have two players, two objects, player and enemy. Obviously, they can have different positions on the 2D canvas. By default, they're stuck to the bottom of the canvas, but they can have any position left and right, which we can control using the X and Y. But then the object can also move forward, backwards, jump up, or fall back down using the gravity. So besides the position of the player, which is X and Y, we also need a velocity in this way and a velocity in this way. So for that, we will go to the constructor and we will set using member variables, so fields. Besides the position, we also want the velocity, two-dimensional velocity. Okay. And this is going to be an object. This is another object. Both have members, an X and a Y. And when we create them, they will look like this. So it will not be immediately evident that this is a position while this is a velocity. What we can do is to have the constructor take just one parameter, just one argument, which is an object that contains two objects inside. In order to construct the sprite, we now need to name. So it receives just one parameter, which is an object that has two data members. There's a position and a velocity. Okay, and the velocity, let's indent it. like this. Okay, so sprite is the constructor, which is this thing, receives just one object, which is this thing. The object has two members, position and velocity. And position and velocity are objects that have two members each, x and y. Okay, we need to construct the enemy in a similar fashion. So this thing is the enemy. And the position is these values, 400 and 100. And let's see if we didn't regress, if the functionality is still the same. So yes, it did. I saved an index.js, I refreshed the web browser, the counter started from 0, the same thing is painted on the canvas. Okay, so the source code is already long. What we want right now, we want to code fearlessly. That means we want to not have regressions. We want to always increment. We want to not be afraid that we're going to lose something. For that, we're going to use the version control system, which is called Git. Let's see how we do that in Visual Studio Code. We create a Git repository here. Okay. We could commit using the native Git tools, which means Git GUI. We have two files, index.html and index.js, correct? The initial commit has the same commit message always, which is initial commit. We can look at the history. So now we can code fearlessly. We're not afraid that we're going to lose important work. And we can always go back in time if something goes awfully wrong with the changes that we create in the source code. Next up, we only have the draw, so the two objects do not move on the 2D canvas. Next up, we want to implement gravity, have the objects fall to the bottom of the canvas, not exit it. For that, so this is what does the custom painting. We need another method which is called once per draw cycle, which is called update. Which does two things. First of all, it paints. And second, it recomputes member values of fields of the current object. In this case, we want to have the objects fall down, which means incrementing the y coordinate. So that's this dot position dot y. So remember that y increases from the top of the screen to the bottom of the screen. So it's 0 and it needs to increase until it reaches this point. So the first player is right now here and needs to fall until everything's black, only this part is red, this rectangle at the bottom of the screen. Okay, so we need to increment the position. We can do it in two ways. This dot position dot y, let's increment it, I know, by 10 pixels at a time, like this. Or we can use the shorthand notation, which is the plus equals operator. Okay, and we're doing custom painting just once, which is wrong. We want to do custom painting at each cycle of painting. Okay, we have just two objects that we need to paint. One named player. We need to call not draw but update. Draw would paint at the exact same spot at each loop, animation loop, because nobody changes the x, the position x, position y, velocity x, velocity y of the current object. So in fact, we need to call update. We'll paint once, we'll recompute the position x, position y, velocity x, velocity y. Then the next loop will happen and it will paint again, recompute the fields of the object player again. The same for the enemy. And the player has painted this part, then this part, then this part. That's why we see an infinitely long vertical red line. And it's probably still painting, but outside of the canvas, way outside of the canvas. So instead of having the previous positions of the rectangle visible, we only want the current position of the rectangle to be red, the rest of the canvas should be black. So we currently have the problem that we paint the player with red, but we do not repaint everything with the entire canvas with black before painting the current position of the player and of the enemy. So custom painting of the player happens here. Before we custom paint the player, we need to make the canvas black again. So how did we do it black the first time? This thing. Control S and refresh. And now how it happens is like this. First of all, there's no color specified for fill, which means black. We fill the entire canvas with black. Then we call animate. Animate calls fill rect. The color is still black, so the entire canvas is painted again black. And then we call player update, which is this thing, which goes draw, and draw sets the canvas context fill style to red. So when whatever is filled from this moment on will be red. So fill rect creates a rectangle and fills it, which is just this thing. Then enemy update is called, which update does draw, which draw sets the fill color to red, which creates a rectangle in here, which is red. So black, red, and red. Everything's correct. And then 60 times per second in my case, because my monitor is 60 Hertz. The animate function is called again. The current fill color is still red, and we fill the entire canvas with the current fill color, which is red. So we will need to actually set the colors before filling rects. So whenever we do fill rect, immediately before we need to set fill style. So there's a pair of fill style and fill rect, and we have a fill rect without a pair. And then also this thing is useless. Okay, so now our players move downwards because their velocity is x, 0 and y. Increasing at each repaint, so 60 times per second. It increases by 10. So that's it increases by 600 pixels during 1 second. Okay. The next problem that we have is that even now the players, the sprites, keep advancing downwards, even if they have left the canvas a long time ago. So we'll need to make the player fall down but stop at the bottom of the canvas and be entirely visible. Next up, we have for each object a property named velocity, which we're not respecting. This property is never used. So we're incrementing the y position, but we're ignoring the velocity. So should be like this. Nothing happens yet. Why? Because velocity.y is 0. Velocity.y is set to 0 here and to here 0 here. Let's set it to 10 for the player, and enemy has y velocity of 0, which means imponderability, no gravity. Okay, so the player drops because it has gravity, whereas the enemy is imponderable, is not affected by gravity, so it hovers. So next up, we want the players to stop at the bottom. So how do we do that? So why do objects get past the bottom of the canvas? Because in the update method, we keep incrementing the y forever. So 60 times per second, the y gets incremented, which means the y never stops at its maximum position. So let's say something like if y is at its maximum position. So this is y axis. The maximum position is this thing, which is this, which is canvas height, minus this thing, which is the height of the sprite. Okay. So we say if this dot position dot y, we add the height of the sprite. So this dot height, and we do not have this height yet. If we control click on position, it navigates to the correct place. If you control click on height, nothing happens. So we want to also set the height here. The height has been hard coded to 150 here. And now we can use in the draw method the height. So whenever we see 150, that should be in fact the height of the sprite. But there's just one place in the custom draw. Okay. So position Y is this thing, plus height, which is this thing. And it already incremented by velocity. So this means the next time we want it to not increment. So then we're thinking for the next time. Velocity dot y. If this thing is past the height of the canvas, okay, then we want the velocity dot y to stop it, be 0. Let's save and run. And the sprite now stops. Stops at the wrong place because it keeps this black rectangle under the player. Now we're going to implement, so this movement is linear, whereas gravity is an acceleration. It has the objects when falling will have different speeds depending on the height. So we do that by having a gravity acceleration. Let's define it. It affects both players identically. 0.2. And the y position is affected by the y velocity, should also be affected by the gravity. Where is plus equals gravity? Okay, so this is just the gravity, extremely slow. And this is the initial velocity y on the OY axis. So we can change the initial velocity, make it always 0 for both players. So now their Y position is only affected by gravity. Let's try to fix this issue. So we see the objects move outside of the canvas. And it's not so why does it move outside of the height? Because we keep incrementing position.y even when this condition is false or true, whatever. Even when the player is outside of the height of the canvas. So we should not do that. we should use the gravity only while the player is above ground. When the player touches the ground, gravity should no longer move the player. So the gravity is an acceleration and changes the speed, not the position. The speed changes the position. Okay, so we can see it's a curve that there's a transition, a curve, speed increases, and then when the players touch the ground, they stop their movement on the OY axis. Okay, so we're very far in the implementation of this program. A good moment to save all, there's no need, and then to commit our changes. Let's look at the changes. This is something that's not that great. This is a ton of trailing white spaces. Can we actually fix this thing? This. Okay. Rescan. So we no longer animate just once the players, but animate them in a loop. We animate them here. We make sure that the entire canvas is not filled with red in here. We have implemented both velocity and gravity. And object height. Hard-coded to 150 for now. All of the players have the same height and width here. So velocity affects the OY position and gravity affects velocity.y. So let's commit. Where is the name of the file and then what? Velocity and gravity. Commit. Next up, let's implement keyboard key. So we will be able to play the game using the keyboard keys. Let's first of all see how we can programmatically read the key that has been pressed using the keyboard. Use the object window, and there's the event listener. Add event listener, and we want the event named key down, and next up we'll have an arrow which is the name, the list of attributes, and then the body. Okay, so we want to see what's inside of this event. Console.log event. Refresh, click, and then press the A key. Go to the console. Says that a keyboard event happened with key A and code key A. So you want this part, this property key, lowercase key, this thing. Let's log just the property key, refresh, and press a bunch of keys. So A, S, D, F, G. We can see them in the Google Chrome Developer Tools in the console tab, A, S, D, F, and G. Next up, we will implement moving forward. So moving to the left, which means incrementing X. Okay. So there will be many keys pressed, many keys for moving. We're going to use WASD. So that means A means moving left and D means moving right, all lowercase. So W lowercase, A W lowercase, and D lowercase. So we can use the alternative structure named switch on what? On the, what is this thing? A string, a character, event dot. So we're switching on event dot key. And in case D, which means move right, what should we do? The player's velocity should increase in the direction OX. Okay. Let's run. We should click in here. These are the arrow keys. So refresh, click, and press the D key. Okay, we can see that the D key was pressed. We can see that we were inside the event listener arrow function because line 78 has logged in here. But then even if we increased the velocity.x, because nothing uses velocity.x, there's no references, the player does not move. So let's make the player move. So similarly how we did it with position.y, find all references. So we're using velocity to influence the position. The same way we do it for y, we need to do it for x. Control S to save. We're probably going to have a similar logic, not to have the player exit the canvas by going left or by going right. Let's save and see how it works. D. By pressing D, the key down event handler is called, which just increases, which just sets the velocity x to 1, which means start moving in the rightward direction. If we press D 7 times the speed will not increase. It's a constant velocity. Okay, but what we want is on key down D, the player should start moving. When we key up the letter D, the keyboard key D, the player should stop moving left or right. Right in this case. So for that, we need to implement a similar event listener. So this was for keyboard key down. And now we'll have an event listener for keyboard key up. Okay. So when we press the letter D, something should happen to the velocity. What? I wonder. Okay, so press D. When we key up on D, the movement stops. When D is pressed, the movement will happen. As long as the key is pressed, the player will move rightwards. When we stop pressing the D key, the movement will stop. Okay, similarly to how we moved to the right, we will implement moving to the left. So again, we're using WASD keys on the keyboard. So that was D. We need an A, which sets speed in the opposite direction of OX axis. So it's not going to increase the X, it's going to decrease the X. So the delta will be negative, so -1. And also when it's moving left, by keeping the A key pressed, when we release the A key, the player should stop. We need this case, but with A. Okay, let's reload. So we go D, stop, A, stop, D, stop, A, at the same time D and A. So if we keep D pressed and key down A, key up A, the movement stops, even though we're still pressing the D key. So press D key, press A key, release A key, D is still pressed, should move rightwards. That's because this is called, then this is called, and then this is called. This is never called. So whenever we key up on any of D and A, we stop the movement even if we still have one of these keys pressed key down, which is not intuitive, and we're going to fix that. But let's do another commit first. So this is moving on the x-axis, OX. Move left and right. So we're moving left and right by changing position.x. We are respecting velocity.x, and we have two event handlers, event listeners for the window. We have keyboard key down and keyboard key up. We've implemented D to go right and A to go left. Okay, so we'll implement that by knowing which of the keys are currently pressed. So when we press down the key A, we will have somewhere a state where it says that the key A is still pressed. When we press the key D, inside of the same globalish state, we have the knowledge that the two keys are now pressed, A and S, A and D. Okay. So we'll have a object that knows for each keyboard key that we're interested in, such as A, if it's pressed or not. This is a Boolean going to be not pressed by default. This thing. VV. Control X, V, V. Control X, X, X. So the two keys that we're implementing right now and we care about are A and D. So A is left, D is right. And in the function animate, so this function is called, this is the main loop. It repaints the canvas. It paints the players and positions the players correctly. And then it will also manage the state of pressed keyboard keys. So we go if keys dot a dot pressed. In this case, we want to change the player velocity on the x-axis to -1 because we're going left. So going left means decrementing, going right means incrementing on OX axis. Okay. And for the keyboard key D, we're incrementing because we're going to the right. Okay. So this variable is being read from, but not written to. Okay, so we need to not only read from this, but also to write from it. Keys A pressed is this thing. And on key up, it's no longer pressed. Okay, on key down, letter D is pressed. On key up, letter D is no longer pressed. Okay, let's see. So we go D. On key up, nothing happened. But we can fluidly move from left to right. Nothing sets the velocity to 0. It's only being set to -1 or to +1. So it's either going to the right or to the left, never sitting still because velocity.x is never 0. So we do that each animation frame by resetting before setting. So we want this thing which is being set to be reset. So we're resetting player velocity x, and then if needed, we're going to set it either like this or like that. In here, we're resetting the canvas, and then in here, we're painting a red rectangle. In here, we're painting another red rectangle. So when we key up, it stops. When we key down, it goes. And if I press both at the same time, -1 will be of the biggest priority because it's being short-circuited. This is being evaluated first. Keys A is pressed. When I press both A and D at the same time, so it will move to the left when I press both A and D at the same time. We will need to fix this issue. So again, the issue is press D, goes to right, press A, going to left has better priority than going to the right, even though A and D are both pressed at the same time. Okay, so how we'll do this is if we press A should go left, but if you press D, it should now start going right because although A and D are both pressed, D was pressed last. So we need to have a variable that stores the last key that was pressed. So that will be last key. And we only care about key down. So when key down D, we say last key equals to D. And we key down, and when we key down on letter A, we want to say last key equals to A. And then when key A is pressed but was the last one to be pressed, then we will go left. If the key D is pressed, okay, and the exact same thing for the letter D. It will go right only when the letter D is still pressed and was the last to be pressed. Let's see how that works. So we go A and D at the same time. Previously it went left when you pressed A and D at the same time, but A first and D second. So key down A, key down D, key up D, and although A is still key down, it doesn't start moving to the left. Okay, let's do another backup. So this was for pressing A and D at the same time. Okay, so what we did, we needed a global object and a global string, and in the object we know how many keys are pressed at the moment and which are those, and this one tells us whichever key was keyed down last. Okay. Next up, so we want WASD. Let's implement the keyboard key W for jumping. So we're going to go to the key down, and similar to the A, that's actually we should put D, A, and W in a certain order, or either in alphabetic order or in WASD order. Okay. So when we press the letter W, the keyboard key W, keys.w is pressed, last key equals W. We need a W in here. W. Okay. So we've added a W in here. This allows the letter W that's being set here. We've implemented key down correctly. And we need to implement key up in the same way. So W and W. W, 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 and W. Okay, so moving left and right is continuous while you press key down D, it will keep moving to the right, whereas jumping up is just a one-time action. You key down on the W key, it jumps just once. If you keep the W key pressed, it will not jump a million times. So that's why we don't even need to know or implement the event keyboard key W up, because it only does something when you press the W key. So when you press it down, it jumps once, that's it. You can keep the W key down as much as you can, as you want. It will not do anything. When you key up the W key, it will also not do anything. So how do we specify that? On key up W, we do nothing. We don't care about the last key. We don't even need W in the keys. So when W is pressed, we just influence the player. So we on player dot. So from outside the objects, we're not influencing X and Y. Also because we do not know their values, but we can also not influence the gravity. That's a given. That's a global. But what we can influence is the speed of the player. When we press the W key, the player should jump. So if the player is here, the player should jump here. So that means negative movement on the OY axis. So that's velocity dot y is decremented. So minus equals, and then I don't know, 10. Okay, so D W. D, W. Woo! It jumped twice. Woo, woo, woo. And we're still waiting. So jumping 3 times, that's very outrageous. When we press W down just once, we do a velocity decrease by 10. So that means that velocity of the y was 0, now it's minus 10. When we press a second time, the velocity is minus 20. When you press the third time, velocity is minus 30. But then velocity over time will automatically decrease because of gravity. And gravity is small, 0.2. So 30 minus 0.2, it takes many frames for the speed to actually be positive. So it's minus 30, but plus 0.2. So that's minus 29.8. So it still keeps going up. At the next frame cycle, so 60 frames per second, it will increase the velocity.y with 0.2. So in 60 times per second, that's 12. So minus 30 plus 12 per second, and then it takes about 3 seconds for the velocity to become positive again. And meanwhile, the player is way up above the canvas. Okay, so W, W, W. 1, 2, 3, 4, 5, 6. Okay, so with that, player 1 is very advanced, and we're going to start implementing player 2, which we called enemy. So let's do again a git commit. That's it. Short and sweet. Jump. Player 1. Okay. Next up, we are going to use WASD for player 1, which is this guy. And for the player 2, the player on the right hand side of the screen, we're going to use the arrow key. So arrow up, arrow down, arrow left, arrow right. So let's do that. For that, we're going to need to implement very similar switch cases for player 2 as we implemented for player 1. But we need to know what is the name of the key down key for the arrow keys. So let's refresh and press the arrow keys. So it's arrow right. Let's copy these. That would be player 2. D is right, so arrow right. Keys dot arrow right. Now we have the following problem. The keyboard keys are used by two different persons. There's player 1 and player 2. Player 1 playing on the left part of the keyboard, so using the keys WASD. Player 2 is playing on the right hand side of the keyboard using the arrow keys. So when we say last key, we actually do not want to mess up the last key for player 1 when the last key was pressed by player 2. So that means that last key should be a property per the sprite object. So in here, we go this dot, where are you? This guy. No value. We don't need this anymore. Okay. So this would be, let's actually rename the two players. So we have player 1 and player 2. How do we rename this thing without support? Rename symbol player 1. Go. Rename symbol. Where are you? F2. That's player 2. Okay. Player 1 velocity correct. Switch for player 1. Let's actually end this switch statement. Player 1. When key D is pressed, we want player 1 in here. Okay, player 1 dot velocity correct. For arrow right, we want player 2 dot last key is arrow right. Okay, this thing, arrow left. And the same thing for W. This thing is, I know, arrow up. So whenever we press the arrow up, second player's velocity should jump, so be negative on the OY axis. Correct. And for key up, probably the same thing for player 2. So that's arrow right instead of D. And arrow left instead of A. And we need to make sure the object has these values. Can't we copy? I double clicked and then it selected the text. So one click selects the row, double click selects the text. Let's arrow left. Okay. Let's see where we are. In animate, player 2 doesn't do anything. The case for key down, player 1 correct. Case for key down, player 2 correct. Case for player 1 key up correct. Player 2 correct. So next up is editing the player 2 in here. So let's do that. We have the canvas. We have players 1 and 2, and then we have movement. Player 1 movement. And we need a player 2 movement. Okay, so this is player 2. Keys. So A is the left key. And this is player 2 velocity. And this is arrow right. Okay, let's read. So animate. We call ourselves, so we call animate again. On the next 6th of a second. 60th of a second. Yeah. And then canvas, player 1 and 2, custom painting and X and Y positions. So the player computes the X and Y positions, but the gravity is set in stone. We only influence the velocity from the exterior of the player 1 and 2. Okay, here we play with velocity, and also we play with velocity in here on arrow up and on W. Let's see how it works. So we want to move the player 1 right. Says that D does not work. Last key is not defined. Okay, where is that? In the animate. This thing. So this should be player 1 dot last key, player 1 dot last key, and this should be player 2 dot last key. Refresh. And let's move the player 1, which is this guy. D player 1 last key, so I did not put dots. Okay. D A jump. A player 2 arrow right. Nothing happens. Or does it happen? Yeah, it happens, but it also moves the left right scroll bar of the web browser. Let's zoom in, Control minus. and okay, arrow left, arrow right, and jump. Jump and go right. Jump. Ooh, man, go left. How many times did I press arrow up? Wow, 20 times. How did I do that? So if I press arrow up once, it gets registered as one arrow up, page up, and one button up and one button down. But then if I keep the arrow key pressed, it's going to register as multiple key downs. This is probably some accessibility feature in the arrow keys. Repeat keys or something like that. I'm beginning to fear that I'm going to lose source code. So let's do another git commit. So we have moved less key to be per user. This means per player. This means it should be a field of the sprite. So commit index.js. We've renamed enemy to player 2. This forced us to rename player to player 1. We did a ton of renames using the feature refactor rename in Visual Studio Code. Direction keys left, right for the player 1, direction keys left, right for the player 2. We needed to duplicate make sure both players have the same left and right movements. Last key is no longer global, is a member field of player sprite. Okay, so this was player 2 movements. Commit. Okay, so now we have movements for both of the players, but the movement is very slow for debugging purposes. We're still programming and we want to see easily these movements. So we want to increase all of the numbers in here. So velocity x should be way faster than 1. So let's try 5. When we edit in one place, we need to edit in 4 places at least. So movements are way more fluid. Okay. Then gravity, not realistic enough. Let's increase this also. So it's 0.2, let's make it 0.7. So move, jump. More realistic, but it doesn't jump high enough. So jumping is that minus this guy, minus 10. Let's make this minus 20. Again, this number appears in 2 places. Okay, so let's see. Woo. And you can jump above the other player. Okay, very fluid. This should be it. Okay, so fast, let's do another git commit. All of the numbers have changed, -1 to -5, -10 to -20, and 0.2 to 0.7. Increase movement numbers. Let's look at the history. Okay, so where? Index.js, what? Velocity and gravity. Move left and right. Looks okay. Next up, we need to do attack and damage. So this is player 1, this is player 2. If player 1 presses a key, such as, I know, space for attacking, for hitting with a sword or with a fist, then we'll draw a rectangle like this. So starting at player 1 and going into the right hand side direction. If player 2 is in that rectangle, then we'll decrease the life, the health of player 2. So the health bar will decrease for player 2 if the rectangle of the hit touches or overlaps player 2. So each player, player 1, player 2, has an attack box. Player 1 moves to the right, so the attack box is like this. Player 2 moves to the left, so the attack box is like this. First of all, so we need to compute when player 2 is touched by the attack box of player 1. First of all, we need to actually see those attack boxes. Those will not come into effect before you press the space key, which is the attack key for player 1, for instance. But now we're going to draw it all of the time such that we can visualize them and implement the attack boxes correctly. Okay, so there's two players. Each player has its own attack box. So constructor position velocity. Let's see what's happening in here. We have the position xy, velocity xy, height 150, and width is this 50, hard-coded here. And then we need the last key. We'll also need the attack box. So we go this attack box, and this is an object. So the attack box has an X and a Y, which means a position. And it has a width and a height because it's a rectangle. Okay. Let me also add in here a width because this dot width 50, and we're going to replace this 50 here. Let's see where else do we have a 50. Nowhere. Okay. Position of the attack box is the position of the player, of the sprite. So we go this dot position. width, let's make this, I know, 100, and height 50. So it's multiples of 50, which means width is 1, height is 3, and a tag box is width 2 and height 1. Okay. And when we paint, when we do custom painting for one player, for a sprite, which is this method, we're painting one rectangle, which is red, which is the player. And we'll also need to paint a second rectangle, which is the attack box. So that's c dot fill rect x, y with height. So x is the same x of the position. Okay. Attack box has the own properties for width and height, which we are going to use. This dot attack box hard coded width. This dot attack box dot height. Okay. Let's see how that works. So it looks like a Tetris piece. So 2 and 3. Okay, let's move around. Woo. Okay, the player should be red. The attack box should be a different color. We need to see how the attack box is layered on top of the player. So that's done with the fill style. Let's make this thing green. Okay, we can move around. So we have the attack box, but then the two players, player 1 and player 2, are really hard to tell which one is which. So we'll need a way of having different colors for the two players. That means inside of the sprite class, which is the class that we instantiate twice for the two players, we'll need to also have a color. So this dot color equals a parameter that's received via the constructor. Okay, so the same way that we passed in velocity, let's also pass in the color argument parameter of the constructor. So this value is placed here, which is placed in here, which is then being used here. Okay. Now they should both be black. Not really. So random colors. Let's actually assign colors to them. The first one should be red. And player 2 should be blue. Okay, and now it's easy to tell apart that player 1 is red and player 2 is blue. And it's a good moment to do a git commit. So we've painted the attack box. Okay. Next up, we need to detect when the attack box reaches the opponent. Okay, so we've painted the attack box. Now it's time to detect when collisions occur. So we have the movement of the second player. In here we will detect collision. And this is player 1 and the attack box of player 1. So player 1 is handling damage to player 2 if this OX, so this X coordinate is greater than or equal to this X coordinate. Again, this is the OX axis. So if player 1 dot left is less than or equal to this thing, which is player 1, this is player 2 dot left, and this is player 1 dot left plus collision box, whatever, plus attack box dot right, something like that. Okay, so that's player 1 dot position dot X plus or just the attack box, because we don't know the attack box in which direction it is. Okay. Okay. Plus player 1 dot attack box dot width. And if this thing is greater than or equal to player 2 dot position dot X, then we're going to debug something. So console log player 1 damages player 2. Refresh. And let's make the player 1 touch player 2. And nothing happens. Why not? So if player 1 dot attack box, yes, there's no X position for attack box. The attack box has a position. Attack box has a position and a width and a height. And player 2 has a position or not. Yes. Yes, and now we're handling damage each and every repaint animate frame. problem that we have here and we want to fix is that if we put player 1, so player 1's attack box touches player 2, and then we go past the player 2, the condition is still true. This one. So if this is way, way bigger than player 2 dot right, we're still damaging the player 2, which is wrong. So we're damaging the player 2 only while the attack box of player 1 touches the rectangle of player 2. So this means we'll need two conditions. Okay, so if player 1 attack box position X plus player 1 attack box width touches player 2 position dot X and player 1 attack box position X, this thing is less than or equal to, so this point is in here in the player 2 dot right, which is player 2 position dot X plus player 2 dot width. Let's test this thing. Damage, and no damage anymore. Correct. Okay, so this gives us the collision detection when the player 1 touches player 2, because both player 1 and player 2 are on the same value of y. So for instance, if I jump, where are you? Go back red. Can be in such a circumstance where the collision box, the attack boxes of the attack box of player 1 certainly does not touch player 2. So if you jump, then yeah, the attack box does not touch. When it fell down, it touched for a millisecond. So this should be registered, this should not be registered, this should be registered. So we considered the attack box of player 1, its left and right sides of the attack box, but now we're also going to need to consider the bottom part of the attack box of player 1. The second I fear that I'm going to lose work, I'm going to do a git commit even if they're too tiny, even if the git commits are too small. So this is player 1 attack box left and right collision. detection. Okay, next up. So back to the animate method. This animate method runs each paint frame, so 60 times per second, and this knows about the two players at the same time. In here we implement logic which knows that on the canvas there are just two players. Okay, so player 1 damages player 2 only when this rectangle touches the user. If this rectangle is above the user, like in here, it will not touch. So we need to write that logic. Okay, so we have 1, 2, and we'll need 2 more conditions. So one condition for this side, one for the other, one for this, and one for that. So for the bottom one, let's copy and paste this thing, or both. Okay, so player 1 attack box, the lower side of the attack box, position dot y plus player 1 attack box height. So this thing should be less than, does it happen? Should be less than player 2 dot position dot y. No, should be greater than, because y, this is how the y or y coordinate decreases. So this part should be, for instance, in here, which means the y for player 2 plus something extra. And this coordinate is attack box position dot y plus attack box height. This should be greater than player 2 dot position dot y, correct. And then for the superior one, player 1 attack box position y should be greater than or equal to player 2 position dot y plus player 2 dot height. So there are all of the combinations possible. So that's if player 2 is in the middle of a jump, player 1 just moves under player 2, you press the space keyboard key to attack, so player 1 attacks player 2, but then player 2 is in the air. So rectangle, the attack box of player 1 totally does not touch player 2, so no damage will be done to player 2. And what's wrong in here? This trailing pair of ampersands, which is the logical AND operator. We have 1, 2, and 3. Let's see how this thing works. So we go over here, do not touch, and jump. Oof. So the conditions are wrong. Player 1 attack box position X plus player 1 attack box width greater than on player 2 position X. We've already seen this condition work. And then player 1 dot attack box dot position dot X less than or equal to player 2 position X plus player 2 width. So these two we already know they work correctly. And then we've added this part. Player 1 attack box position Y plus player 1 dot attack box dot height greater than or equal to player 2 position dot Y and player 1 dot attack box dot position Y. So all of the Y's are inverse. So this is a greater than and a less than, and this is a greater than and a less than. So position dot Y, this superior one should be more than the bottom of player 2. If it's more, then it doesn't have, yep. So OY, this should be less than this, player 2 dot bottom. Okay, this is it. Okay, so move and jump without touching. Oof, damage. Get out. Damage. Jump on top. Oof. Okay. And the other one, player 2. Let's jump a bit, player 2. Damage. Correct. Okay. Next up, we want player 1 to attack player 2 only when the attack key on the keyboard was pressed, and then only for a period of time. So player 1 pulls out the sword and then for a number of milliseconds attacks with the sword and then puts the sword away. So let's see how that happens. Even if the attack box of player 1 overlaps player 2, if player 1 did not attack, then there's no damage there. And that's player 1 dot is attacking. Okay. Let's define this member of the sprite. So we set it in here. This dot is attacking as the default value, which is Boolean false, hopefully. And then we need a way of starting to attack and then stopping the attack. So pull out the sword, attack a number of times, and then put the sword away. For that, we're going to need a method for attacks. Okay. When we press the space key, the attack method will be invoked. This will set player 1 as is attacking. So this dot is attacking. This is set to true. And then after a number of milliseconds, we want to stop the attack. So that's done with set timeout. We have a handler and a timeout number. Let's do a handler and a number. Let's make this 100 milliseconds. Okay. After 100 milliseconds, we want to reverse this thing. Okay. So member variable is attacking. Set to true, set to false. And also read from in here. Okay. Let's actually test this thing. So now, although we draw, we paint the attack box doesn't really work because player.isAttacking is never set to true. Okay. Okay. So we want player 1 space bar key on the keyboard to be the attack key on the keyboard. For that, we need to know what event.key is for space. Save, reload, and then press the space key. And this is the result, this thing. Where is it? It's actually the space string. Okay, so player 1, when key down the space, then player 1 should attack. Okay, so player 1, where are you? Touches player 2 with the attack box. And now we press the space bar. We can see space bar being logged here as key down this thing. Key down console log event key. Then for 10 milliseconds, for 100 milliseconds, the player dot one is attacking is set to true. So that's 1/10 of a second. That's 60 frames. That's 6 frames, which in here it says 1 plus 4. So it's only 5 attacks instead of 6. Okay. And then this thing is probably, I'm guessing, the key up event. This guy, key up and the key. Okay, so successful. Let's do another git commit. So player 1 is attacking. The attack starts when space key is pressed. The damage condition has grown substantially. It was just detecting the left and right of the attack box. Now it also detects the top and bottom of the attack box, plus the player is attacking. We set is attacking to true and false after 10 milliseconds, and we set it to false by default. Okay, so this would be player 1 attack. Okay, So player 1 can handle damage to player 2 if the player 1 wants. Whereas player 2 cannot, because the player 1 is damaging player 2. Okay, so it's interesting when the attack boxes of player 2 reach player 1 and the attack box of player 1 reaches player 2. If both players press the attack key, the opposite player gets damage, so both of the players get damage at the same time. So next up, we move player 1 over player 2, we press the attack key, and a random number of damages is done to player 2. So there's 5, there's 5, constant 5, but again this 5 is wrong because 10th of a second, which is 100 milliseconds, divided by 1000 milliseconds should be 6 damages per second, and then the number of damages will depend on the refresh rate of the monitor. In my case it's 60 Hz, but on 144 Hz refresh rate monitors there will be way more than 5 damage points to player 2. So we want to not depend on the refresh rate of the monitor when deciding how many damage points player 2 takes. So that means that after we detect a collision, immediately we make player 1 not be able to provide damage. This way, this count will always be 1. Okay, so the count, we can see it's always 1 per me pressing the space key on the keyboard. Next up, we're not going to paint the attack box, so the rectangle that's green currently, which is painted in the draw method. So the attack box is going to get custom painted only if we are attacking. Control S. How do we Control KC? Control Z. How do we format? Like this. Control S. Let's see the effect. So the rectangle of the player is being shown, is being drawn at all times, but since we're not attacking, we're not seeing the rectangle. Oof. So fast. It's too fast to be visible. Very strange. Okay, so now that player 1 can attack correctly, we need to do two things in order to have player 1 attack correctly. So we want player 1 because it's facing player 2 to attack correctly. So player 2 is facing player 1. So that means the attack box should be to the left of player 2. And the attack box of player 1 should be to the right of player 1. How do we do that? Let's put this attack box in here. So start to the left of the player 2 and end at the right of the player 2. So for that, we're going to use attack box.position, and this is a X and Y object, which can start at the position.x, and Y can start at this dot position.y. Did we save? Dot x, and y is this dot position dot y. Yeah, so we're not painting the attack box correctly. So we need to compute this point and then width and height, not the point that's the X and Y of the player. So not like this, but like this. So we start at this attack box position X, this attack box position Y, and then attack box width, attack box height. Okay. And now the attack box is no longer stitched to the position of this. This means that during each frame, we will need to make sure we give the correct coordinates, X and Y, to the attack box. And then the attack box is already painted correctly at respecting only the attack box position, attack box width, and attack box height. Okay, so the current status is that the attack box remains always at the start position X and Y of the player. So we'll need to, every time we paint the rectangle of the player, we'll also need to recompute the X and Y position of the attack box. So for instance, we can do it in here. So we go this dot attack box dot position dot x equals this dot position dot x, and the same thing for y. Refresh, and now the rectangle of the attack box is recomputed correctly, its coordinates. Okay, so both attack boxes are facing to the right, which is wrong. The player 1 should face to the right, and the player 2 should have the attack box facing to the left. So let's see. So that's OX-axis for the attack box. So this thing, let's see if we subtract 50 in here. Now both attack boxes are facing left, which is wrong. We want the attack box of the player 1 to face right and the attack box of player 2 to face left. So that's why we're going to introduce a new thing, which is called the attack box offset, which is also a pair of X and Y. So this dot attack box dot offset dot X. And we're going to introduce the attack box offset X and Y. Oh. Attack box, so this should be offset. Okay. So we're going to create the two players, player 1 and player 2, in different ways with different offsets for the attack box. This means that we need to pass the attack box offset via the constructor arguments. So that's attack box offset. And now's a really good time to see if we can do a backup. So we're passing attack box offset that we're storing into offset in attack box. Attack box position is always computed at each frame. This was fixed before. We always painted the attack box at the wrong coordinates, the coordinates of the player, which now, because of the offset, at least the X of the attack box will move to the left for just player 2. For player 1 will stay as it is. Okay, in here for player 2 we will move the attack box position X to the left 50 pixels. This in here we're stopping the attack, so we're attacking just once, giving just one damage point. This is Visual Studio has formatted the source code. Okay, so that's start. So let's start this thing. Okay, so now we have the two players. We'll pass to the constructor of sprite the offset of the attack box, which looks like this. For the player 1, so the attack box is facing to the right, and for the player 2, the attack box is facing to the left, and we already know that the magic number there is -50. like this. And in here, if we put 50, things work okay. But minus 50 minus is plus 50, so this thing needs to become a plus. And let's see. So what we see here is correct. Damage happens. And we do not have yet an attack key for player 2. So we have player 1 being able to attack player 2, but player 2 still cannot attack player 1. So we'll need identical conditions, an identical condition to this one for when player 2 is attacking player 1. Because this just cares about attack boxes and the player, so the rectangle of the second player, of the other player, and the attack box of the first player. So we know we will need to copy this entire block below to detect collisions from the player 2 towards player 1. That's why we're going to extract this thing as a function. Let's see if it has a refactor. Extract to function in global scope. Let's do that. New function. This thing is called player is player collision. Okay. Let's go there. So we're seeing if player 1 is in collision with player 2. So we will need these two players. But we cannot name, so we need two arguments in this function. First, we will call this function with player 1, player 2, and then we'll call this same function with arguments player 2 and player 1. So would be so let's make this player, one player and another player. Okay. So this one player is player 1. Okay. And then we have the player 2. How do we rename this thing? Let's do it manually. Okay, so one player should be the only player in the left-hand side of the comparison operators. 1, 2, 3, 4, 5, and 6, and another player should be only in the right-hand side. 1, 2, 3, 4, 5, 6. Looks okay. Okay, let's go back to is player collision. In here, player 1 is trying to damage player 2. Control S, and then let's refresh. Move closer and damage. Great. It works. Okay. So now that this collision from player 1 to player 2 is way more simple, we can have also the detection of collisions from player 2 towards player 1, which means if player 2 is attacking, so all of the occurrences of player 1 should be replaced with player 2. And we say player 2 damages player 1. Save. Player 2, player 1. Player 2 is attacking. And let's shrink this thing. Okay, but then player 2 still cannot attack because it does not have a keyboard key for attacking. Okay, so very similarly to the way player 1 attacks, when we press the space key, we will implement that pressing the down arrow key for player 2 will attack. Let's copy this block. And this will be probably arrow down. And player 2 will attack. Let's see if that's the case. So player 2 and player 2 damages player 1. Let's get both damaging each other. Okay. Arrow down is pressed but cannot damage because it's not near enough. Looks very, very well. Let's see if we can do a git commit. So we have the attack box visible at all times. We're computing the position X of the attack box correctly. We have an attack box offset configured for both of the players. One is facing left. We've extracted this method. So let's just say that. Oh, no. Player 2 attacks correctly. Including with the new arrow down key being the attack key for player 2. Okay. So since everything seems to work okay, movement of players, attack boxes, attack key bindings, we can stop logging excessively and also not show the attack box by default. We're only going to show it when the attack key is pressed. Okay, So I'm the left. And then player 2 attacks, moves out, comes back and attacks again. So let's do a git commit. We've removed the extra logging. We're only showing the attack box if is attacking. And we've populated the index.html file with a ton of divs such that the game starts to look like a fighter game. So in this red square, we will have the countdown timer. In here, we will have the health bar of player 1. In here, the health bar of player 2. So we've implemented the health bar of player 2. It looks like this. The game starts. The health bar is completely blue, which means 100%, 100 health points. And then player 1 comes near to player 2, delivers damage, and the health bar goes to 0%. Let's see how we did this. So when player 1 hits player 2, we're decreasing the player 2 health. So originally was 100, and then we go -20 to 80, then -20 to 60, etc. And then we use that health, which starts 100 and goes to 80 as a percentage. So could be 100% or 80%. And player health is configured and declared inside of the sprite constructor as the rest of the fields of the sprite class. And inside index.html, we have a div with ID player 2 health. This is blue, and this starts at 100% width and goes to 0% width. Starts being completely blue, and then shrinks. Let's look at the differences. So inside of the class sprite constructor, another member variable is defined health 100, which is an integer. And then instead of logging, we start the health at 100. We decrement it each time a damage occurs. And then we use that integer as percentage. In index.html, we have a player 1 health. We have a player 2 health. And the two colors. So blue is the percentage of health left, and yellow is the maximum possible. So that's player 2 decreasing health. So now we have implemented the decreasing health for player 1 correctly. Let's look at the changes. We had when player 1 hits player 2, the health of player 2 decreases. Now it's the other case. When player 2 hits player 1, we're decreasing the health of player 1 by 20. And then we're decreasing the width of the div player 1 health by and we're setting it to the health percent. So if the health is 80, we're setting it to 80%. And we've copied the enemy health divs into player health div. Enemy, let's change the text here. So this is player 2 health and player 1 health. And I've only replaced player 2 health with player 1 health. And let's see, this health bar is full, 100% blue. It's going to decrease going towards the center, so towards the descending timer. The same thing happened also for the health of player 1. The bar was decreasing to the left. Well, it should decrease to the right, and again the health bar for both player 1 and player 2 should shrink towards the middle, towards the descending timer. So that was done with display flex, justify content flex end with 100% and with 100%. Let's player 1 descending health. Okay, so this will be the final version of the game. We can go even further and implement the game descending counter, the timer, implement game over screen, implement high scores, and most importantly, implement the graphics. So the background graphic, the graphic of the two players, and the attack box. An action with the sword, the circular action with the sword. And also style the health bars with some PNG images. So let's see the end result. We have player 2, player 1 health bar, player 2 health bar, the placeholder for the descending timer. Player 1 plays with the keys WASD. So W for jumping, D right A backwards, and it hits with the spacebar, whereas player 2 moves with the arrow keys, jumps with arrow key up, and hits with arrow key down. And player 2 wins. Thank you.